Hi friend, welcome again. Now in this lecture we will discuss about stabilization of operating point in collector to base bias circuit. In our previous lecture we have studied about collector to base bias circuit and we have found that IB equal to VCC minus VBE upon RB plus RC and IC equal to beta IB as we know that, and VCE equal to VCC minus ICRC. We have neglected the effect of base current because it's too less than collector current. Now our first point is change in operating point due to temperature. When temperature increases, then reverse leakage current ICO also increases. Due to this, ICO will increase with temperature increases and beta will increases, which will increase the collector current IC. When collector current IC will increases, in that case VCE equals VCC minus ICRC. Here collector current will increase, in that case VCE will decreases with the increase in beta and IC. When VCE will decreases, so that's why according to this relation IB will decreases, which will again decrease the collector current. Thus collector current IC is not allowed to increase rapidly and the operating point will tend to stabilize. From here operating point tend to stabilize. Again discuss. First point is due to increase in the temperature beta will increases, so that's why IC will also increases, and according to relation VCE equal to VCC minus ICRC, VCE will decreases with the increase in IC, and this decrement in the VCE collector emitter voltage will decreases the base current IB, and according to relation IC equal to beta IB, IC will also decreases. So operating point tend to stabilize because here collector current is not changing rapidly. Our next point is here RB is the resistance connected after RC and VCC is supplied voltage with both resistance, so that's why here RB is acting as a feedback. This is acting as a feedback. If RC will increase, then VBE will be decreases, so that's why IC will also here decreases. So this feedback will decreases the change in operating point. This dependency of IB on the feedback tend to oppose the change in base current. That's why feedback will oppose to change in base current. If base current is not allowed to change, in that case IC will also IC will also oppose change. So operating point will be fixed. Due to this feedback, this is also known as voltage feedback bias circuit. That's when this is voltage feedback bias circuit. Here we have discussed 2 points. Now our third point is what happens when this transistor will be failed or burn out. In that case we will replace this transistor with another transistor, then the current gain, that's when beta of the transistor will be changed. So what will be the effect in that case? So our next third point is change in bit current gain. Change in current gain beta after replacing transistor. In this case we know that VCC will be equal to beta time of IB RC plus IB time of RB plus RC plus VBE. VCC is equal to beta time of IB, that means IC is replaced with the beta IB, beta time of IB RC plus IB time of RB plus RC plus VBE equals 0. So VCC minus VBE is equal to RB plus 1 plus beta time of RC IB. So the value of IB is given as VCC minus VBE is written as VCE minus VBE upon RB plus 1 plus beta time of RC. Here the value of VB is too small, so we can neglect this. IB can be written as VCE upon RB plus beta time of RC. Now IC is equal to beta time of IB. So IC equals beta time of VCE upon RB plus beta time of RC. When we will divide IC with IB, in that case these both denominator will be cancelled with each other and beta will be fixed as the both numerator and denominator of the right hand term of the above relation contain multiple of beta. The change in the value of beta will not affect IC to a large extent. Also, the relation VCE is equal to VCC minus IB plus IC time of RC is equal to VCC minus ICRC, because IB is negligible, which will also remains constant. So operating point of this collector to base bias circuit is fixed and self adjusting due to the voltage feedback. Now our next point is drawback of this collector to base bias circuit. What is drawback of collector to base bias circuit? Drawback: here the circuit has the tendency to stabilize the operating point against the variation in temperature and the value of beta, while it has some drawback is that the resistance RB not only provide a resistance RB is not only provide a DC feedback, it also causes an AC feedback. It also causing AC feedback. Because here if temperature will be changed, in that case here the current IB will also change, so that's why there will be some AC effect. The AC feedback reduces the voltage gain. So voltage gain reduces which is not desirable in amplifier circuit, which is not desirable to amplifier circuits. So this circuit cannot be used as amplifier circuit. while it will stabilize its operating point. The reason is basic reason is behind it that RB is only not providing the DC feedback, it's also causing AC feedback, so the voltage gain will be reduces, so it cannot be used in amplifier circuit. In amplifier we need the higher voltage gain, so that's why this circuit cannot be used as an amplifier. Thanks.